In the present video, I will be explaining some problems related to compound interest. There will be problems in which we apply the formula of present value. The first problem says like this. What sum of money will grow to 4,000 in 7 years at 9% compounded monthly? We have the information of the interest, this 9%. So R equal, I'm going to type here that R equal 9%, and is compounded monthly. This percent is annually. The percent that we receive is always annually. Because it's compounded monthly, so I'm going to take note that there will be 12 periods of compound interest. So I'm going to type here n equal 12. And of course, in the formula of present value appears always the value I, that is the periodic rate of interest, the interest in each period of time. So the interest in each month. So because the annual interest is 9%, in each month we have that the interest is I equals 0.09, so this 9% divided by 12, because there are 12 periods. So this is the periodic rate of interest. So when we are solving the problems, we are going to be using this I. Okay, let's see what will be the solution. We always are thinking in the time. So in our mind, we have like a timeline, a line that represents the time. And if we think that this first point is today, I noted that in 7 years, the money will grow. So the money will grow to 4,000 in 7 years. So after passing 7 years, we have a point here when the value of the money is 4,000. And we want to know what is the amount of money that will grow to that. So this 4,000 is here, and the amount that we are going to calculate will be the amount that is at the beginning. So this is the present value. So the amount here will be the P that we want to compute. So I'm going to use the formula of present value. So you need to observe from the problem that you actually need to compute the present value. Then you can use the formula of present value. I'm going to take note of this formula here in the top corner, in the top right corner of my screen. So here, P equal S multiplied by 1 plus I to the power negative N. We have S, that is the future value, 4,000. We have I, that we know that is 0.09 over 12. And we can calculate n. We don't have it so far, but we know that n is the total number of compounded periods. So it will be just multiplying the time times the number of compounded periods per year. So the number of years, the time in years, times the number of compound periods in a year. So n will be equal t times m. And because t is 7 years, so n will be 7 times 12. So that means that n equals 84. And I can use the formula of present value to compute now the present value. So P, substitute S equal 4,000, n equal 84, and I is the quotient that we have here. So we have that P equal 4,000, open bracket, 1 plus 0.09 divided by 12 to the power negative 84. One of the things that I'm going to do in this video is to explain how to use the calculator SHARP 520 for solving this problem. So the thing that I'm going to do is just type in the calculator. I get my calculator. This is in the screen now, and type first 4,000. Obviously, for this, I will be using the key exponent key that is here in the calculator, y to the x. We are going to use also the bracket keys that appears in the formula. These are the bracket key, and the key plus minus that change the sign of a number. Because this number is negative 84, I need to use it when I type, if I want to type the 84 negative. Okay, so I type 4,000, 4000, Then I open bracket. Here is the bracket, open bracket, and 1 plus 1 plus 0.09 divided by, this is the division key, divided by 12. So I cross the bracket that appears in the formula, cross the bracket, and raise this to the power. So raise it to the power minus, so I use this key, the sign key, minus 84. Okay, so in a scientific calculator, always what I'm typing appears here at the top. Okay, so just press the equal sign, the equal key, and they give you the answer. 2,135.381063. Because we need, this is money, we are going to round this to 2 decimal places. So the answer will be 2135.38. So this is 2135.38. That solved the first problem. So it will be the money that will grow to 4,000 in 7 years at 9% compounded monthly. Good. So this will be a first example. A second example that could be useful could be this one. Find the present value and the compound discount of 25,000 due in 6 years and 3 months if interest is 6% compounded quarterly. Again, they give me the interest that we know that is always annual. So this is the interest per year. And we notice that this interest is compounded, is calculated every quarter. So M equals 4. There will be 4 quarters in a year. So there will be 4 compounded periods in the year. So M equals 4, and then the interest I'm going to use in the formula of compound interest, I, will be 0.06. This is the 6% divided by 4. So again, now it's easy. They are asking me for the present value, so they already told me. So now I know that when I make the timeline, today is here, and in 6 years, 3 months, the money the value of the money will be 2,500. So this will be 2,500 at this time. So this is the future value, and I need to compute the discounted value. And this discounted value, the present value, assume that you need to pay this 25,000 in 6 years, 3 months. But because you are paying this today, you are going to get a discount. So the discount value, it will be the present value. And this compound discount is the discount that we are going to obtain for paying earlier. So we are not going to pay all this interest. So this interest will be called a compound discount. So let's compute this P, and after we get the P, the present value, the compound discount will be just the subtraction between S and P. So S minus P. Okay, so let's compute first the time. Let's type here again the formula of the present value is P equal S open bracket 1 plus I to the power negative n, and we don't know n, so we should compute first n. Yeah? So let's see, n equal T times m. In this case, the time is 6 years, 3 months. This is the time in years. Typing in years will be 3 over 12. Remember, 1 over 12 is 1 month. 1 year over 12 is 1 month. So 3 over 12 will be 3 months. So I'm going to type n equal 6 years, 3 over 12. So now this number is the time in years. 3 over 12 times 4. This is a mixed fraction, you can simplify. This is the same of 1 over 4, but before canceling, multiply 6 times 4, 24, plus 1, 25, 4. 25 divided by 4, and the 4 cancels, so the answer will be 25. Anyway, because we're practicing how to use the calculator, let's see how to do this with the Sharp 520 calculator. So I get my calculator, And now, because this is a fraction, I will be using the key fractions. See this key that appears here in the calculator, AB over C. Okay, so it will be 6, 3 over 12, so I type 6. After the whole part of the number, I'm going to type the fraction, so you need to type the symbol fractions. So A, B, C key appears here. Remember, when I'm typing the key is appearing here, so you can follow easier. The symbol that appears in the screen of your calculator is like this, maybe a little smaller. Here I have amplified this. So 6, 3, now the numerator type 3, again the key fractions, if you see, over 12, so the key fractions, and 12 is the denominator, so I'm going to type 1, 1, 2. So C3, 12, multiply by 4, so I'm going to multiply by 4. So this gives me, and then press the key equal signs, and that gives you the answer, 25. So n equal 25. That we already know before, yeah? Another way to notice that it's 25 without using your calculator is noticing that 6 years, because every year has 4 quarters, this will be, 6 years will be 24 quarters, 6 times 4, 24. And these 3 months will be 1 quarter more, so it will be 25 quarters. So this is now n in quarters, the number of quarters, the number of compound periods. And this is the number that I'm going to put here in the formula. So let's type here the formula with n equal 25. S is 2500 and I is 0.06 over 4. So let's type it here. And then use again the calculator for computing this. And again, the calculator, you know what keys to use, the key power, the key brackets, and the plus minus key that is here at the bottom. So we type 2500, open brackets, 1 plus 0.06 divided by 4, close the bracket, and raise this to the power negative 25. So this is what we have here. Press the equal signs. So in the screen of your calculator, of course, you'll see what you are typing. Press the equal signs, and you notice that the answer is 1723.01, rounded to 2 decimal. Let's type it here, 1.723.01. So I can answer now that the present value is 1723.01, 1,723 with 1 cent, $23 with 1 cent. Okay, so this is the present value, but they're asking me also for the compound discount. And we know that the discount that we received for paying earlier will be the future value minus this present value. So the compound discount will be x minus p. So d equal s minus p. So it will be 2,500 minus 1,723 with 1 cent. You made the subtraction again in your calculator, but now every calculator can do it. So I'm going to type $776.99 is the final answer, is the discount that you received for paying earlier. Okay, so that's answer this second question. And we have a last example of a question in which you have to compute the present value. The last problem for this video will be the following. Determine the sum of money that accumulates to 1,600 at 5% compounded quarterly in 6 years and 4 months. The reason I want to answer this question is very similar to the previous one, is because in this case, 6 years and 4 months will give me a number of periods that will be a fraction. What to do in this case? The nominal rate of interest is 5%, so I'm going to type R equal 5%. That is compounded quarterly, so M equal 4. And also, we know that if this is the case, I will be 0.05 divided by 4. So the periodic rate of interest will be 0.05 divided by 4. So to get the solution, again, we have the timeline in our mind. We know that the 1600 appears at the end. So today is this point, and 1600 will be the amount of money that we have at the end, because they say that determine the sum of money that accumulates to 1600. So in 6 years and 4 months. So these 6 years and 4 months are in the future. And in this moment, and at that time, we are going to have what we are going to accumulate to 1600. Okay, what will be the amount at the beginning? So in this moment, we recognize that we need to compute the present value, and that the formula of the present value is the one that we know. When we are going to compute the number of periods, in this case, when we multiply t times m, we have that this is 4 over 12. So 4 over 12 multiplied by 4, because there are 4 periods per year. When you do that, you will notice that will be a fractions, yeah? Because now here, when you, for example, simplify, will be 4, will be 1 at the top divided by 3, and you will notice that the denominator doesn't cancel in this case. What to do in this case? Let's make this multiplication using our calculator. So this is the calculator, and again, I'm going to use this key ABC, and I type 6 fraction 4 fraction 12. This is 6 4 12. Multiply by 4. And now that I multiply by 4 equal. So this is that is the answer that the calculator tell me, 2513. So 25 quarters and 1/3 of the quarter. You can use the key second function of your calculator, and they give you the answer in fractions. It's for some of you that know a lot how to use fractions. You multiply 25 times 3 and add 1. 25 times 3, 75 plus 1, 76 over 3. But anyway, with the number in the screen, use the second function key, and again the key ABC in this order. Second function key, and then ABC, and the calculator immediately tell you what is the fractions. So the fraction is 76 over 3. So the answer here is 76 over 3. Okay, some of you are going to do it without calculator, of course. You can do it without calculator. But anyway, if you have the calculator and you have problem doing this, you have your calculator for doing it. If you have a calculator with this key. Okay, so now we have n, and now that we have n, the only that we need to do is use the formula. P, it will be equal 1600 will be S, n equals 76 over 3, and I is 0.05 over 4. So let's type it here. You get your calculator for doing that again. With your calculator, 1600, 1600, open bracket, 1 plus 0.05 divided by 4, cross bracket, and then to the power, let's see here the key power, minus 76 over 3. So minus, again, minus 76, and then ABC 3. So this is that giving you this in the screen of your calculators. Okay, press the key equal, and they give you the answer. 1168.001. When you round this number to decimals, because this number is greater than 4, so then you need to type 1 here. So it will be, you cut the number and type 1 at the end. So this will be $1,168.01. By the way, these are dollars. So we have that the sum of money that accumulates to 1600 in this time is 1,168 with one sentence. And that finish this problem and also finish the explanation about present value. In the following video, I will be giving you explanation of some utility of the present value. So let's stop here, and in a future video, I will be giving you explanations about the use of the present value and other things. Thank you.